Good morning, students. In this today's class, we are going to discuss the topics which we have left. The first thing we are going to discuss about the characteristic of all flip-flops. In today's class, we are going to discuss this concept, and the subject is DE. It's there for EC, CSE, EE, and IT. Okay. So these are the things we are going to cover. In today's class, we are going to see the characteristics of flip-flop. In that, the basic concept what we have discussed till now is all about. When we want to discuss anything about flip-flop, we have to know that flip-flop is a device which is going to store a bit of information, whether it is 0 or 1, because our digital information deals with either 0 or 1, right? In the last class, we discussed about the types of flip-flops, that is nothing but SR flip-flop, JK flip-flop, and we do have a D flip-flop and toggle flip-flop, right? So these concepts we have covered, and we left with one concept, that is we left with T flip-flop. T flip-flop and D flip-flop. So this already I have covered. I just want to tell you the difference of this. Since both are what? Both are having the unary operator. That means both are using a single. T is the input over there, and we're going to give a clock pulse to it, and we're going to produce the output as Q and Q bar. So these are the two output end. Whereas for D, it is also the same. Here we are giving a D is the input value. Since it's working as a clock pulse, we are just giving a clock pulse to it, and the output is Q and Q bar. Clock pulse depends upon the types of it, whether it is edge trigger or it is going to be the level sensitive, depends on it. We are going to take the value for the particular clock pulse. Next thing, we have seen the D flip-flop, truth table, D flip-flop designing, whereas for T flip-flop we have only seen its designing part and then the block diagram. In today's class, I am going to tell you how the T flip-flop and D flip-flops are different, since both are consist of a single input, unary operators. Both are having a single input. Based upon that, how it is going to work it, that particular thing I'll tell you, and then we'll go through the directly topic of our today's discussion would be characteristics equations of flip-flops. All types of flip-flops, we are going to discuss the characteristic equation. That also I'm going to discuss in today's class. So first thing, I'll tell you the difference of it. In T flip-flop, what is the difference, and D flip-flop? So basically in T flip-flop, what I'm doing, I'm using a D flip-flop. In that, the first thing, I need to design the latch, that is by using NAND gate cross coupled, that is nothing but output is connected to the input of it, input is connected to the output of it. That is done. Next thing, we are passing both the things with one more NAND gate, here also one more NAND gate. This is connected, both are connected to what we are giving? We are giving the clock pulse. So we first give the clock pulse, right? Then that's the output is Q, that's the output is Q bar. Since what's the input over there? D is given. Similarly, for D flip-flop, what is the thing we are giving? We are giving, I'll draw it for D here. This is for D. T I'm drawing here. So for T, what we are doing? We are again connecting two NAND gate, that is cross coupled like this. This is the latch we had. Again we are passing with the one more NAND gates, right? These are two NAND gates. Output is Q and then Q bar. Here simultaneously we are giving clock pulse to it, right? This is done. Next thing, we have to decide what is the input value over there. It is T, toggle. For toggle, what is there? Again, it has some input, right? So this will be directly short circuited. Okay, whereas in D flip-flop, the output is connected to this way. This is the cross coupled. That means the input of the first one, it is passing to the output of the next one. And in D flip-flop, we are going to connect one NOT gate. That is extra thing. And one more thing would be, first we'll pass one NOT gate to it. Next, the input of the first will be passing to the output of next, like we do have for JK, right? In JK also we have given likewise. This is thing we have already discussed, how the D flip-flop and T flip-flop is going to work. That two particular part, when we want to design it, we are going to design that two flip-flops, D and T, in this particular way. So in this way, you are going to design the D flip-flop and T flip-flop. D is call it as transparent latch also, where we are going to give NOT gate to it, whereas toggle flip-flop depends upon the input value, and it has single inputs. Both the input is short circuited, and we are giving the one clock pulse to it. By using the clock pulse, we are going to work for that particular flip-flop. So when this cross coupling, if you are giving, so see, if you are giving this kind of cross coupling, that means when you are passing to it without giving this NAND gate, suppose I am not giving NOT gate, then this is behave like a T. Okay, this way, this is behaving like a T. Whereas for the second one, if you are giving NOT gate to it, suppose you are connecting a NOT gate like this, then this is become D. So difference of D and T would be this only. Here we don't have any NOT gate, whereas in this we do have a NOT gate. And this cross coupling is there for it, for T. For D it is not there. Okay, actually this is for T flip-flop, toggle flip-flop, and this is for D. That's the difference of both the flip-flops. So till now we talk about JK flip-flop, SR flip-flop, T and D. The next thing we are going to understand its characteristics equation that will be helpful in designing and converting the particular flip-flop. That means if you had SR flip-flop, how it is going to convert into other type of flip-flop, that is JK, D and T. So that conversions, that means to convert SR flip-flop into other types of flip-flops, so we need to know it. It's two equations. One is the characteristics equation table. There is a tabular form, that is truth table we are going to use. And second part we are going to learn is excitation table. These two tables decide how do we convert SR flip-flop into all the type of flip-flops. Likewise, next conversion would be JK flip-flop into all the three types of it, that is SR, toggle and D. Then vice versa, remaining toggle into, how do we convert into D, JK and SR. Likewise, we left with D. How D is converted into SR, JK and T. So these conversions of flip-flops also it will be useful for designing the given conditions. So that also we do have, and we are going to see by using into its characteristic equation. By looking into characteristics equation, we are going to design all the types of flip-flops. So students, so we are proceeding with the characteristic equation of flip-flop table. So here, what is the characteristics equation is describing the operation, the logical operation, how the logical properties. What is the meaning of logical properties? When you're giving 0 and 1s, those are called what actually? Those are nothing but the logical operators. So when we're giving the logical values to the flip-flops, how it is going to describe its operation. That means what kind of operation the flip-flop is going to do it. If it is JK, if it is SR, if it is toggle or D, how it is going to work it. On what basis your flip-flop is going to work depends upon the characteristics table and depends upon the characteristic equation it is going to produce the output. So here, first flip-flop we are considering is JK. In JK, what is the two combination we do have? 0, 0, 0, 1, 1, 0 and 1, 1. Right? This is the inputs we are giving. J is behaving like a set and R is behaving like a reset. So when we are giving these two values, how your next state Qn plus 1 is going to depends upon, suppose when both are 0, 0. So what's the value we are writing over here? We are writing is Qn, right? The next state. What is n plus 1 means? Next state depends upon the output of the present state. So what is the present state? It is Qn, and the command what we are writing for it? It is no change. Because whatever Qn value we do have, it is exactly keeping Qn as it is. So when we are giving J is equals to 0, right? So J is equals to 0 means what? It is behaving like a reset. So this is output is 0. When K is equals to 0, again it is behaving like a reset. So for that what I can write? I can write it is what? It is equals to 1. So when J is 0, it is behaving like reset. When K is 0, it is behaving like set. Clear? So when we are giving both are 1, 1, the present state is taking the complement. Complement means it's a Qn bar. If it is Qn for the first condition, it is taking 1, 1 means it is nothing but Qn bar. Clear? So that's how your JK flip-flop is going to work. Similarly, in D flip-flop, the basic thing for D flip-flop is what? It's a transmitting latch. When we want to see that particular thing, it is what? It's taking the data. So while we are giving the data, it is taking the values. How it is? It is single. Single means it can 0 or it can be 1. When it is 0, the output is also 0. When it is 1, the output is also 1. That means 0 means it is reset. 1 means it is set. Right? It depends. What is the Qn plus 1? It is the next state. When it depends upon the present state, And the next state, when we want to see that one, how it is going to work, that is also explained by the characteristic equation, right? So that's how we wrote it for D flip-flop. Next thing we are going for toggle or T flip-flop. In that same we are giving 0. 0 means it is taking the present state. When we are giving 1, it is taking the complement Qn bar, right? So it just resembles like here. When it is giving 0 0 for it, it's becoming like Qn. When we are giving 1 1, it is becoming Qn bar. Because over there JK flip-flop we do have a 2 inputs, whereas in this we do have a single input. So in this, when we are giving 0, it is Qn. When we are giving 1, it is becoming Qn bar. So this is what Qn means, present state. Next state is becoming similar to the present state. There is no change. So that's what it is, no change. When we are giving 1, so what is that 1 means? It's Qn bar. So what is Qn bar means? It is what? Complement state. So based upon these two particular thing, your characteristic equations we have to develop. So these are what? These are called characteristic equations. So how do I get this? On what basis I am writing this one? So see, D and Qn plus 1 both are same. That means depends upon D value, your next state is going to obtain. Suppose D is 0, next is also 0. If D is 1, next is also 1. That means Qn plus 1 depends upon the value of D. Next one, JK flip-flop. In JK flip-flop, I am considering these two columns, right? So see, first is J and Q bar. If J is there and the value of Q is what? 1. That means this two, by using the J and K value, I am going to decide the factor. So what is that? J is equals to 1 and we are taking the complement of the value will be this one, Q bar. Or you can remember directly, when both are 0 0, it is Qn, both are 1 1, it's nothing but Qn bar. If you want to write its equations, we can write in this way. J Q bar plus K bar Q. So depends upon the values J and Q bar, it is going to obtain its characteristic equation. Likewise for T. How do we mention for T? When T is 0, that means T complement. Q is what? Q. When T is equals to 1, it is becoming Qn bar. So T bar Q plus T Q bar. That's nothing but T exclusive OR with Q. So we written characteristic equation for your D flip-flop, your JK flip-flop and your toggle flip-flop. So depends upon these characteristic equations, your flip-flop is going to obtain. So likewise for SR flip-flop, characteristic equation is similar to this truth table. So that's what I have not mentioned in this specifically. So students, so we just want to write the value. So we wrote it in this way. Once again, you see truth table, it's important. Based upon the characteristic equation and the excitation table, we are going to convert the flip-flops. Okay. So first thing, for JK flip-flop, we have written both are 0 0. Present state is Qn. If both are 1 1, the state we are just taking is Qn complement, the complement of it. How do we obtain the characteristic equation? To obtain the characteristic equation, we are looking into these conditions. Right? So what is K is equals to 0 means is what? K bar. What is the present state we had? It is Q. Plus. Next, when K is equals to 1, so we can take K value or J is also 1 in this condition. So since I am taking one input here, another input I am taking as J. Right? So what is the value here? Q bar. So we obtain J Q bar plus K bar Q. Similarly for D flip-flop. D flip-flop depends upon present state. What is there? That is also resemble the same value. When D is equals to 0, the next state is also 0. When D is equals to 1, next state is also 1. That indicates your Qn plus 1 depends upon the D flip-flop input. Likewise for T flip-flop. So if you want to write T flip-flop, what is the first value? T is equals to 0. That means it's T bar, T complement. And we are taking the input value Q. Plus, next, T is 1. That is nothing but T. And we do have is Q bar. So we wrote it Q bar. So both are same T, T. So it resembles the value like A complement B. A bar B plus A B bar. Right? This is nothing but A exclusive OR with B. We can write like this. So we wrote it. So based upon the values T bar Q plus T Q bar, that resembles in this way. So we obtain the characteristic equation for your D flip-flop, JK and toggle flip-flop. So based upon this and the properties what we have taken for the previous conditions, all types of logic diagrams you have to keep in your mind so as to convert the given flip-flops into the respective asked flip-flops. Make a note of it. So students, once we done with the characteristics of the flip-flops table, and next we are proceeding with master-slave flip-flop. So we are taking one example of D flip-flop, how the master-slave is going to be designed. That I am going to tell you how and what is the use of master and slave flip-flops. We'll consider one example by taking the D flip-flop, and we're going to conclude with the master-slave. So for master-slave, basic thing what you need to remember is, when we want to design the master-slave flip-flops, first criteria is, one is becoming like a master flip-flop, another is becoming like a slave. Slave in the sense depends upon the master input, it's going to produce the output. So likewise, I'll take two kind of flip-flops. Likewise, I'm considering. So what is the concept of ours is master-slave. Suppose we are taking the D flip-flop. Okay, so first, when we are designing the master-slave, one is becoming master of it. That means depends upon the value of it, it is going to produce the output. So here we do have D. Suppose we are giving clock pulse. I'm mentioning here, suppose enable, right? I'm giving two simultaneous value for this enable by using the clock pulse. So another one, this has become master, so this has become the slave, right? Again input, what is the input value we are giving? We are giving D. Input for the second flip-flop also we are connecting, and we are giving this D. So this D depends upon the output of it. So what is the output? Suppose this is the output for Q, right? For D flip-flop, what actually we are using? We are using NOT gate, right? In the previous also we have seen it is using NOT gate. Both are simultaneously passing to the clock pulse, right? So output for that is what? Again, this is second one, we are just writing as Q, and the next is Q bar, right? For this also we can mention over there, it is Q bar is their output. So here is the first input we are giving, depends upon the D value, input value of it. This is becoming your master D flip-flop, right? And this is becoming your slave D flip-flop. So working, it depends upon the clock inputs, what we are giving, and how it is going to get the value. So this is your enable, or you can write it as clock also, right? Here I'm mentioning, again it is enable. That means if I'm giving as 1 to the clock pulse, that means your clock pulse is high, like this is a clock pulse. For that particular scenario, what is the value? 1 is coming here. So since it is 1, this has become 0, right? That means it is going to disable the second flip-flop, and the first flip-flop is going to work when we are giving the positive clock pulse, and the clock pulse needs to be high. If it is high, then this is going to enable, master is going to enable, and the slave is going to disable based upon the inputs what we are giving for this particular NOT gate. Suppose if you are giving 0, the 0 means, suppose this is 0, this is 1. Likewise we have chain of pulses, right? If I am giving 0, the complement of 0 would be 1. In that particular scenario, your slave, it is going to activate, or it's going to produce output, depends upon the taking the value from this Q also, right? The input of this Q and the clock pulse we are giving, and your D flip-flop is in slave condition. So this is the way your master and slave kind of flip-flop is going to be used. The importance of this flip-flop is that this particular flip-flops is going to use for the constructions, and it is work as an inverter because we are connecting one NOT gate. And a change in the output of D flip-flop, if you are putting any kind of change in the output, it can be triggered only by using the transition of clock pulses. That means from 1 to 0, 0 to 1 transition if you are doing, depends upon that transitions only, your master slave flip-flop is going to work. So depends upon this transition. Transition means what? What is the value we are giving to the clock pulse? Based upon this clock pulse, if it is 1, this is going to work. If it is 0, this is going to work. That's how you're going to get the outputs based upon the master slave. So this is what external triggering we are giving, right? We are giving the clock pulse. So by using this clock pulse only, your master slave JK flip flop or SR flip flop or any other kind of flip flop is going to work. So that's it for today's class. In the next class, I am going to start the excitation table and more concept of flip flops.